Don't forget to subscribe and ring that bell.
We have come to the end of the journey, which is the practice AP Calculus AB exam for the year 2014. We are going to do free response question number 6, which is the last one on the exam. And we don't get a calculator. It's okay. Just breathe. In through the nose, out through the mouth. All right, let's start free response question number 6 and get this show on the road. Number 6 reads, consider the differential equation dy dx equals 1 minus 2 over x squared times y minus 1. Ooh, I feel a separable differential equation coming here, where x cannot equal 0. Let y equal f of x be the particular solution to the differential equation with the initial condition, there it is, f of 1 equals 2. Find the slope of the line tangent to the graph of f at the point 1, 2. We're starting with something easy. We are starting with something very, very easy. Find the slope. Slope is the same thing as the derivative, which is also known as dy dx. And they gave us that. This is the derivative. Not only do they want the derivative, they want it at the point 1, 2. So when x is 1 and y is 2. So this is really, really easy. My x value of 1 is going to go in for my x, and my y value of 2 is going to go in for my y. That's it. Man, that's a gimme. Whew, layup. So let's do this work right here. I've got 1 minus 2 over x squared. My x is 1. I'm going to take that, I'm going to multiply it times y, which is 2, minus 1. Well, let's do some simple algebra. Told you we ain't going to need this calculator. Okay, 1 squared, well, that's just 1. 2 over 1 is 2, so I have 1 minus 2, which is negative 1, times. Well, 2 minus 1 is just 1, so it's negative 1 times 1. So my answer is negative 1. That was really, really simple to do. 6b. To me, these are simple as well. But let's go through it and make sure it's also simple for you. On the axis provided, sketch a slope field for the given differential equation at the 9 points indicated. Let's keep in mind that the given differential equation, okay, the given differential equation is 1 minus 2 over x squared times y minus 1. Okay, that's the differential equation we're given. And please, you see how there's 9 dots here? Okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Do not start putting things here and here and here. You don't need those, okay? You don't need those, so stop creating work for yourself. What I need to do is figure out the slope at each one of those coordinates. We actually just figured out a slope from 6a. Well, I'll come back to that in a minute. Okay, in order to figure this out, okay, I need to know my x and my y, because I need to plug in a value for x and a value for y. So I'm just going to kind of do this table here and figure this out. And I'm going to start with this. When x is negative 1 at 3 locations, negative 1, negative 1, negative 1. The y values for that are 0, 1, and 2. So that's that first. Okay, that's going to cover these 3 points, all right? Now, let's look here when x is a positive 1. There's 3 points where x is 1. And the y values here, again, are 0, 1, and 2. That is my next 3 coordinates. And last but not least, x is 2 at 3 spots. Okay, these 3 spots right there. And again, my y is going to be 0, 1, and 2. So I just got to fill out this column. Now, if we go back to 6a, we just figured out the slope, negative 1, okay? That's at the point 1, 2. So let's go ahead and fill that in. when x is 1 and y is 2 right here, we know we should end up with a -1 for my slope. That's nice that they did that for us. But that's just so nice. All right? So let's go ahead and figure out the derivative for this first set right here I'm going to do in blue. If I throw a -1 into the bottom and square it, it will be a +1. So I'm always going to have 2 over 1, so it's always going to be 2. Okay? 1 minus 2 is going to give me a -1. So I'm always going to multiply -1 times whatever y minus 1 is. In this case, it's 0 minus 1. Okay? -1 times a -1 will give me a +1. So my slope is +1. -1 times this. Now, this is 1 minus 1 because my y is 1 now. That's 0. Okay, that's nice. And now my y is 2. So it's 2 minus 1, that's just 1. -1 times 1 is -1. Okay, so those are my three slopes for the line there. And if I want, I could put them in there right now. So let's start with -1, 0. That is a slope of 1. So it goes up like this, -1, 0. Okay. Slope at -1, 1, that slope is 0. So that's going to be a horizontal line. And the slope at -1, 2, well, that slope's a -1. So that's going to be coming down at a slope of 1. So that's what that one column of slopes is going to look like. Okay, good. Let's do the next set right here. Right? Guess what? Now if I put a 1, a +1 into this x in my derivative, I still get 2 over 1, which is 2. And that first parenthesis is still 1 minus 2. So I'm going to have -1 times something, -1 times something. I don't have to do the bottom. The bottom is already done. We already figured that out from 5a, or 6a, not 5a. All right? What happens if I throw a 0 into my y? I get a -1. -1 times -1, well, that's +1 as well. Okay. When I throw a 1 into my y here, 1 minus 1 is 0. Anything times 0 is 0. So I've now completed these 3 slopes. Okay, 1, 0 is a +1. It's going to go up, slope of 1. 1, 1 is a horizontal line, a slope of 0. And 1, -2, or excuse me, 1, +2 as a slope of -1. That will be down. It's the same exact thing. These ones right here, these slopes right here, are the same as we graphed right here, those slopes. That's not, you can see the numbers are identical. Let's try the 2's, where x is 2. I'm going to move this over here to the left. All right? We'll do that in green. We'll scroll down a little bit just so we got a little bit more space here. Okay. Now I'm going to put a 2 in for all my x's. Okay. If I throw a 2 in this bottom here for x, okay, that is 2 squared is 4. Okay. And 2 over 4 is a half. So I have 1 minus a half in this front. So I'm always going to have a 1/2 times something, a y minus 1. 1/2 y minus 1, 1/2 y minus 1. If I throw a 0 in here, okay, I get -1. Half of -1 is -1/2. Okay. If I throw a 1 in here, 1 minus 1 is 0. 0 times anything, well, that's 0. And if I throw a 2 in here, 2 minus 1 is 1. 1 times anything is itself. So this will end up being a +1/2. Those are the 3 slopes I get to plot. So let's start at 2, 0. That's a -1/2. So it's going to be not quite 1. It's going to be less steep. All right. Still horizontal line right here. And at 2, 2, I'm going to do a +1/2. So instead of being 1, it's going to kind of be less steep like that. All right. So that's good. I mean, it's patience. Just go through, fill this table with a simple math, and draw the corresponding line. Okay, so to me, that's easy. It just takes time and patience to go through there and not make a mistake because you're going fast. Don't go too fast, okay? Don't lose points because of speed, okay? Don't do that, okay? All right, so that's it, and we are done with 6B, and I'm going to move this bad boy back over here. Oh, yeah. I knew this was coming. Find the particular solution for y equals f of x to the differential equation dy dx equals 1 minus 2 over x squared times y minus 1 with an initial condition of f of 1 equals 2. Okay, so that means I need to find the particular solution, my friends. It's in orange. The solution that satisfies that when x is 1, y is 2. This is a coordinate. You better train your brain if you haven't already. Anytime they give you something like that, that's a coordinate. All right? So what I'm going to have to do is I'm going to have to take my equation here. I'm going to have to put all the x expressions with a dx on one side and all the expressions that have y, okay, with the dy on the other side. And I'm going to have to integrate both sides, all right? Which is not that tall of an order, my friends. All right, so let's do that. Let's rewrite what we got here. We'll start in blue. I've got dy dx equals 1 minus 2. You know what I'm going to do right from the get-go? Let's change this right from the get-go. I'll wait. I'll wait until you see it. Y minus 1. Okay, so this is what we have. Let's multiply both sides by 1 over y minus 1. What's going to happen is this will cancel with this. And on the left side, I also have to do 1 over y minus 1. All right? Nothing cancels on the left side. On the left side now, let's multiply it by dx. This will cancel with this. I've got to do the right side the same thing to balance it. Multiply it by dx. So what I have left over at this point on the left side is 1 over y dy. And on the right side, I have 1 minus 2 over x squared dx. So you see how I got my x's and my dx's on the right side, my y's and my dy's on the left. Let's rewrite what we got. 1 over y minus 1 dy equals 1 minus. Now I'm going to have to integrate both sides. It's always easier if I can work with non-fractions that have exponents. So this is what I was talking about, how I'm going to wait to do. I'm going to bring this x squared, I'm actually going to bring it up and negate the exponent. So minus 2x to the negative 2 dx. That will be a lot easier to integrate because at this point, I need to integrate both sides. Okay, and this is going to be a lot easier to integrate than this fraction was. Okay, so let's do this, all right? Left side is just a rule. You guys should know this rule, all right? This is the ln of y minus 1, but don't forget, there's no bounds. We need to have plus a c, all right? Now, when I integrate the right side, the integration of 1 is just x minus. I add 1 to this. Okay, that becomes x to the negative 1. I still have my 2, and I divide by that new exponent. All right, and again, plus c. Now, keep in mind, even though we have a plus c on both sides, there is no guarantee that it's the same constant. So I like to say c1 and c2, because people sometimes just cross that off. No, you can't just cross that off. You're going to have to figure out what c is based on this initial condition. So you can't just get rid of it. They're like two different c's. Like one might be 5, another one might be 13. One might be negative 4, one might be 8. Maybe they're the same, but chances are they are not, okay? So let's clean this up a little bit more. I'm going to clean this up right here because now if I'm going to have to do some algebra to solve for the c, I don't want to have a negative exponent. So I've got the ln of y minus 1 plus c1 equals x, okay? If I'm subtracting a negative, that's going to turn into a positive, okay? And this is going to come down. So it's 2 over x to the positive 1, okay? Plus c2. All right, so we are good to go now. We can start doing some algebra to solve for my c. And speaking of c, All right, I hit the red thing here. I want to try and isolate my y. So I'm going to subtract C1 from both sides. So I've got the ln of y minus 1 equals x plus 2 over x plus, if I have a constant and I subtract another constant, my end result is still a constant. I could put C3 there if I want, but now I only have one C in there. I only have one constant. So I'm just going to call that C. I want this to work at what point was given? 1, 2. So I want this at 1, 2, when my x is 1 and my y is 2. Now, you can get rid of the ln, add 1 to both sides. You can do that. But I see something here that you should know. Let's see if you pick up on this. If I put a 2 right in here, I end up with the ln of 2 minus 1, which is the ln of 1. Gentlemen, ladies, everybody, okay? The ln of 1 is 0. That's one of the things I expect you to know. The ln of e is 1. The ln of 1 is 0. This happens to show up very nicely here. So if I plug in my y, I'm absolutely going to plug in my x right here and here. My x is 1, okay? My y was 2, all right? So let's continue this bad boy. Equals, okay, x is 1 plus 2 over 1 plus c. So this is 1 plus 2 plus c. So it ends up being 3 plus c. Well, now this is really easy. Therefore, c has to equal -3, because 3 and -3 give me 0. Okay, so this is going to help me figure out that final equation they're asking me for. Right here, which I'll do in this funky blue. This was our equation before we started to figure out what C was. Now we have C. It's -3. So I'm just going to put a -3 in for the C right here. And then I'll worry about isolating that Y. So I have the ln of y minus 1 equals x plus 2 over x minus 3, because my C was -3. All right. Now let's get y equals. So I got to get rid of the ln and the 1. Okay. So first of all, one thing you should know, another thing. If ln and e cancel and give you 1, e and ln of whatever value you have here also cancel and give you x. So I'm going to come over here and make this base e to this whole side, and I'm going to do base e to this whole side. Okay? These cancel. Y minus 1 equals e raised to the x plus 2 over x minus 3. People, one more step and we're done. Let's add 1 to this side and add 1 to this side. Please, after all that beautiful work, please don't put the +1 in the exponent. Okay? We've got y equals this e to the x plus 2 over x minus 3. This is what you had. You're adding 1 here. Don't put a +1 here. No. You've done so much nice work. Please don't mess it up by putting that +1 right there. Okay? This is your answer. We're done. This is the exact solution that satisfies the given differential equation. Okay? It satisfies this differential equation with this initial condition. Okay? And that answer is y equals e raised to the x plus x over 2 minus 3 plus 1. We are done. We are done with the 2014 practice exam. Glad you are here. Like the video, ring the bell, follow me, because you will get notifications when I put up new videos. You want to leave a comment below? Go right ahead. I- I like talking to people. It's fun. All right. I'll see you guys later.
Don't forget to subscribe and ring that bell.